Hi, Math Nines. All right, we are going to talk about interpreting graphs of linear relations. All right, example one. Tommy is paid a daily salary and commission to sell riverboat cruises. As a salesperson, he recognizes that it's important to know his sales in order to determine his commission. He's considering using a graph to calculate this amount. Looking at the graph, what do the variables P and S represent? So a good place to look for the variables is along the axes. So this one is S along here. So S, and then it represents whatever it says here. So that is the sales. And P equals, that's going to be up here on the y-axis or the independent or the dependent axis, sorry, and that is his pay. Okay, question, is it appropriate to join the points with a straight line? Now that doesn't always have a simple answer. So I want you to think about this, okay? Any line is actually a series of dots. Okay, I can make a line by doing, if I do it straight, I can do a straight series of dots. And then when my dots get further apart, it doesn't look so much like a line anymore. Okay, so given that any line is a series of dots, sometimes whether we can connect the points depends on how close together the dots would be. So what I mean by that is, let's do a couple of examples. Let's look at a couple of examples. So if my independent variable down on the bottom here is time, oops, if this is time, I can pretty much always, I can't think of an example when you couldn't do a line because time is continuous. So there's no point where I could draw a line down here and say, oh, there's no corresponding time. There's no corresponding time here. So in that case, I can do a line. All right. But let's say instead of it being time along here, we've got a lemonade stand. Okay, and this is sales at, oh, I'm actually going to make it number. So this is number of lemonades sold. And up here is our income. Okay, how much money did we bring in? All right. So if this is a lemonade stand, my scale might go from 0 to, oh, let's say 20 because that's easy to graph, okay? And my income is up here. And I definitely could put 20 distinct dots. I'm not counting them or anything. Maybe it's more than 20. I definitely can put 20 distinct dots there. And I'm not going to connect those on a straight line because there is no number of lemonades that corresponds with this value right here. Okay, so whatever the income would be, I can't actually do that because there is no number of lemonades because this is a countable thing on the x-axis. Okay, so I would use dots for that one. Okay, but if I compare that to the number of lemonades sold at the PNE in 10 years, okay, that's not going to be 20. It's going to be like, I don't know, 2 million or something ridiculous like that. I just love the lemonades they sell at those fairs. And I can't put 2 million dots along here. So I'm going to put a line. I can't put it through my dots because I don't have that kind of coordination. But it is going to be a line through those dots, okay? Because the dots would be so close together that it would in effect be a line. Okay, so that's the judgment call that sometimes you need to make. Okay, so in this case, if we're looking at our pay, the riverboat cruise sales, although it's recorded in dollars, could be in pennies, right? We could have point something something. So if we did this in cents, it would be from 0 cents to 250,000 cents, 250,000 cents. And I don't think we can put 250,000 distinct dots along here. So joining it in a line is reasonable. So yes, the answer is yes, it is appropriate in this case to join the points with a straight line. Okay? Okay, I'm going to erase some of that because this graph is going to get quite cluttered and I don't need this extra stuff around here. All right, question 2. Tommy is paid $64 a day plus commission of 10% of sales. The table provides some data about his sales and daily pay. A, on the graph, locate the data points for each day. Okay, so Monday, he sold $1,500 worth of cruises and he made $214. So we can start at the 1,500 here and we go straight up and there's the point that we find. And if we go straight across, we can see that that would be 214. That's a reasonable number there. Okay, so this point right here is Monday. All right. On Tuesday, he has $1,250 worth of cruises, so that would be halfway between these two, halfway between 1,000 and 1,500, so we're going to go up. There's the dot. Now, to read this one across here, because we haven't been given it, we need to draw a line that starts right in the middle of this dot and goes over here. My line has to be completely parallel to these grid lines, parallel to the x-axis, okay? Because otherwise I'm not going to get an accurate measurement. Okay, and then I need to look at this scale and figure out what that would be. And the easiest way to do that is to sort of go halfway. I can divide things in half. So halfway between 150 and 200 right here would be 275. And that's a little bit less than halfway, so I'm going to call that 190. So it's about $190 on Tuesday. Okay? And then on Wednesday, he had $800 worth of cruises sold. So that would be, here's 750, a little bit to the right of that. It's going to be up here. So I need to draw my line from that point. And if I'm calling this gap here, if I'm calling this line here 190, then this gap is 10 and this gap is less than that. So this has got to be, let's say 145. Okay, maybe 146, but I'm going to go with 145 because I don't feel like I can really read anything better than to the nearest 5 off of this graph at the scale that it's at. Thursday, he sold 0 and still made $64. So that's that point, this point right here. Oops. And on Friday, he sold $2,010 worth of cruises. So that's going to be just a little bit, like really close to the 2,000. That'll be that point right there. And if that's 250, halfway is 275. So I'm going to call that like 265 because it's a little bit past halfway. I'm going to call that 265. Yeah. Maybe 270. Okay. As long as your answer is reasonable, that's okay. It's not exact. We can't read anything exact off of this graph. Okay. Okay, 3A, estimate how much Tommy would earn if he had sales of $1,150. Or, yeah, $1,150. So we need to find 1,150 along the graph. So halfway between 1,000 and 100 and 1,500 is 1,250, and halfway to 1,150 to 1,250 is 162 or 1,062. So 1,150 is a little bit more than that. So it's going to be in here somewhere. So I need to put a line there. And then where that line intersects with my graph, I'm going to put another line. We didn't have to do this before because we had the dots. We were just trying to find the dots. Now we're having to put our own dots in. So you're paying attention, and your accuracy really matters here. Oops. Okay, so I would call that halfway between the 150 and 200 is 175. I'm going to call that $180. So that would be $180. And how much would he earn? How much would he need to sell to earn $300 in one day? So we're going to start at our 300 and go out to the side until we hit the graph. But wait, there's a problem because there's no graph there to hit. Okay, so this is a good opportunity for me to introduce some vocabulary. There are two words that you need to know. One is interpolate, and one is extrapolate. Okay, interpolate we also call, so interpolate is the verb, interpolation is the thing. Interpolation. And inter, inside, interaction, between. Okay, so it's between or within known data points. So all of the things we've done so far are between our 0 sales and our 2010 sales, dollars in sales. So we've been interpolating so far. Everything has been within those data points that we had. Extrapolate or extrapolation. Exterior, exit, okay, is outside known data points. Okay, so if I have to ask myself before I can extrapolate, I have to ask, does it make sense that the pattern shown by the data extends past the last data point that we have? Is it reasonable that the point for getting paid $300 is going to be on the same graph? And I would say yes, because there's no reason for us to think that the pay rate is going to change just because he's sold more cruises. We don't have that information, so it's reasonable for us to assume in this case that it doesn't. So I'm going to put a line right over top of my graph that I have, and I'm just going to extend it past like that. Okay, so now I can go to my $300 in pay, and I can extend my line out to the graph, and then I can do another line going down from there. There. Okay, so for $300 pay, we are at halfway between 2,000 and 2,500 would be 2,250. I'm going to call this 2,300. 2,300. Oops, 300. Okay, that's my estimate about how much he would need to sell to earn $300 in one day. All right. 4. The graph represents the linear equation P equals S over 10 plus 64. Now, you may be more comfortable if we write that as P equals 1 over 10 times S plus 64, because now this is in slope-intercept form, and we're used to seeing it with these as separate, separate things instead of being a combined fraction, but those are equivalent, okay? So let's use this to do 3a and b. So 3a, we know that sales is 1150, so we'll replace the S with 1150. So pay equals 1 over 10 times the 1150 in sales plus 64. And that equals $179. So our estimate of 180 being read off the graph was pretty good. Okay, let's do 3B. So this time we're given his pay. So it's going to be, we're going to replace the P in the equation with 300. So 300 equals 1 over 10S plus 64. And then I need to subtract 64 minus 64. I get 236 equals S over 10. I'm going to multiply that side by 10, multiply this side by 10. I get S equals 2360. Okay, so our estimate was off by a bit more, but maybe we should go back up and take a look at it. Do you still think it's 2360? Yeah, or 2300? Yeah. You can't read it that accurately off the graph. That's just the way it is. And especially if you've extrapolated, if this line up here is not exactly in position, you're not going to get a good read off the graph. Okay? All right, your turn. Using the graph. I don't have that written down, but I want you to use the graph because it is asking if you interpolated or extrapolated. How much would Tommy earn if he had sales of 240? So pause the video, go and try that, and then come back and check your answers. Okay, if Tommy had sales of $2,400, that would be in here. Oh, we know that this number is actually 2360. So 2,400 would be just a hair above that. And go up to the graph. And then go across. And it's so little. I'm going to say 23 or 305. So close. I'm going to say $305. And then B, how much must he sell to earn 170? Oh, sorry. Did I interpolate or extrapolate? So for the 305, I extrapolated because right here is my last known data point. So this was extrapolated. Okay. And then for B, how much does he need to sell to earn 175 in one day? Let's do this in blue. So 175 would be right between these two. And being careful that I keep my line parallel. And I'm going to call that 1100. Just a little bit over 1100. Okay, and did I interpolate or extrapolate? That was interpolation because it was within the known data. Okay, that is it for the notes. Go and do the practice. Make sure you're checking your answers because that's the only way you'll know if you're getting good answers. If you get an answer and you're not sure if it's reasonable, do fire me an email, let me know. All right, have a great day. Bye.